Okay, so for today, I just wanted to kind of highlight how we can predict whether a double displacement reaction will occur. It's fairly easy once you learn the rules, so let's jump into it. So, first of all, what is a double displacement reaction? It's basically a case where you have two different exchanges happening. So, let's say that you have a compound that has A, B, and then it's reacting with the compound C, D. A in this case is the cation, is positive. B is the anion, negative. C is positive and negative. C is positive and D is negative. And so what we see happening is in a double displacement, these two things flip. So the positive goes to be with the other negative ion, and then the other positive goes to be with the other negative. So how would that look in this example? It would basically turn out to be A, D, so the positive and the negative, but then flipped because we're kind of doing a double exchange, plus C, B. So cations and anions kind of switch twice as much. And so that's a double displacement. And it usually happens when you have two different compounds reacting, and then there's like a shuffling around of the cations and the anions, and you get two new compounds in the product side. This reaction happens, pretty commonly, but then there are cases where it's hard to determine whether the reaction actually took place or not. So we have a couple rules that we use to determine whether a reaction will happen successfully if it's a double displacement. A successful reaction is one that produces an insoluble product. So the reaction will be successful if maybe you end up producing a solid like this, um, or if you end up producing a molecular liquid like water, which is H2O. So if we have a double displacement reaction, we can determine whether it's successful by predicting the products that we have and then finding out whether those products are going to be soluble, so aqueous, or insoluble in the state of solid. So we have MgNO3 2 plus Ki, so we have magnesium nitrate reacting with potassium iodide. Again, this is the positive, negative, and then positive, negative. Nitrate is a polyatomic ion that has a charge of -1. So if we were to do the double displacement, we can predict the products to be Mgi2 magnesium iodide plus KNO3. So if we wanted to balance this reaction, we can just check Mg 1 and then you have iodide. So in that case, you have 2. You need to balance it like that. And then now that potassium has 2, you need to put a 2 in front of potassium over here. So let's check again. Mg, you have 1 on one side, 1 on the other side. You have 2 nitrates on both sides and 2 potassiums on both sides. So we're all set. Now, MgI2, which is magnesium iodide, and potassium nitrate, it's hard for us to determine whether this is soluble or not. So for this, we do need to look into our second slide, which is basically a table with solubility rules. So it basically lets us know whether we're dealing with a soluble salt or an insoluble salt. So again, the salts we get are MgI2, and then you also have potassium nitrate. So if we wanted to check to see whether a compound is going to be soluble or not, we can just check with the solubility rules, which is usually often on a table that will be given to you by your teachers or elsewhere. It's widely accessible on the internet. For me, I got mine through ChemLibrary text. So MgI, the anion in this is an iodide. So I'm going to check to see what the rules are for compounds that have I, which is this line over here. So these compounds generally dissolve in water, iodides, with the exception of silver iodide, mercury iodide, and lead iodide. So that means that MgI is going to be soluble, so it's going to be aqueous. And then potassium nitrate. We have the anion for potassium nitrate being the nitrate ion. If we were to check to see the rules for this ion, they generally all dissolve in water. There are no exceptions. So all nitrates are soluble. So this is also going to be soluble over here. So both our products are going to be aqueous and aqueous. So because they're both soluble, there is not going to be a reaction. So no reaction. Because if you start off with two soluble things and end up with two soluble things, then there really isn't any major reaction happening, because again, our double displacement reactions are successful only if you get an insoluble product or something like a water, which you often get when you're doing a neutralization reaction. Let's try another one. We have iron 2 sulfate reacting with barium hydroxide. We can do a double displacement. This is the positive ion, negative, positive, negative. These positives and negatives need to flip around so that the first positive goes with the second negative, and then the second positive goes with the second negative. We have to do a double displacement, so a double switching. So your products are going to end up being FeOH2, because in iron sulfate, we were having a 2 plus ion that would complement the negative 2 ion of the sulfates. So it means we have to have a 2 plus here. Just going to write that over here. And then you end up with barium sulfates. Is this reaction going to be successful? Well, let's check the solubility rules for iron hydroxide and barium sulfate. Iron is iron hydroxide is a hydroxide, so the anion that we're dealing with is OH. So compounds of OH are usually insoluble, with the exception of your alkali ions, your ammonium ions, and maybe a couple few others. But because iron hydroxide falls into the general category for insoluble hydroxide, we're going to say it forms a solid. And then you have barium sulfate. It's a sulfate. So the anion we're dealing with is the sulfate ion. So compounds of sulfates are usually soluble in water, with the exception of mercury, lead, Sr, and then Ba. So Ba falls into the insoluble category for the sulfates. So we're going to say it's solid. So you start off with two compounds, there's a double displacement, and then you end up producing two different solids. So you're getting two different types of precipitates. So because of that, the reaction will go forward, because we end up getting a solid product. So solid compounds. Whether we get two solid compounds or one solid compound, the moment we get one solid compound, we know that the reaction is going to go ahead for a double displacement. All right. So that's it. I just wanted to take a few minutes to show you how this works. I know a lot of people were asking, so I just wanted to answer that question. If you have any other questions or comments that you would like for us to work through in our next video, then please go ahead and message that into the comment section, and I will try my best to cover those concepts or specific questions that you have.